Right, so I'm going to talk about a North American supergrid, so expanding our Canadian grid to include the United States. Uh, and yeah, what we have a common goal, is to limit the global warming by reducing CO2 emissions from power sector operations. And Canada has made a legal commitment already to moving to net zero emissions by 2050. The United States, it's not legal, but the Biden administration, they say how they want to produce half of its electricity from the sun by 2050. That's solar then. So a potential big step towards fighting climate change. But that would, of course, require vast infrastructure investments and major enhancements to the electrical grid. The challenge, of course, is that solar and wind are interruptible renewable energy sources. Say they don't generate electricity if the sun doesn't shine or the wind doesn't blow. And here you see that chart here is from the US Energy Information Administration. And they say they expect that the amount of renewables in the US will increase from 21% now to 42%, which is way short of the Biden administration's goal. But you can see that the coal is gradually diminishing, but unfortunately, it's still there in 2050. Nuclear is actually diminishing also, although that may change. Things change very fast in this area of new generation. Natural gas is actually increasing, so that's kind of for generation purposes. This is a little bit disappointing. And the Canadian forecast, we can't say much of that because the hydro, the blue thing here, is it pretty much stays the same. The natural gas is declining. Well, I wouldn't say it's declining, actually. It stays more or less constant. What's increasing is wind generation. So that's what is expected. Now here I'm going to talk a bit about the California case, which is very, very special here. This chart illustrates a problem we're having with renewables. It is called the California duck curve chart. It looks a little bit like a duck, and it was developed in 2013, but the recent analysis confirms that the future years shown are pretty close to the reality. What's happening here is that it shows the net load, and net load is actual load less the renewables. So it's net load minus solar and wind during a spring day, 31st of March. As Californians adopt more and more solar rooftop generation, net load during the day will diminish because of this increasing solar generation. And you see with the years how the net load is going down, 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 impinging on what is called basic generation resources. So as the sun disappears, generation needs to ramp up very quickly with mostly gas-fired plants for the moment, which can ramp up quickly, and of course increase imports when they're available. To reach net zero emission, we will need the addition of massive renewables, massive storage, and almost certainly more nuclear to reduce required storage capacity. The amount of storage can be reduced by increasing the amount of baseload generation, for example, by nuclear. This would mean more renewable curtailment unless the extra renewable generation can be exported via a supergrid. So here's the monthly curtailments by CAISO, the California Independent System Operator. And you see these peaks there, curtailment, that it means a generation that can't be used to supply the load. And that, as you can see, as the years advance, you're going to have more and more solar curtailments as more and more solar panels are put online or on roofs. Of course, this is a bit of a pity that all this curtailable. Now, if we could export all that excess solar energy, that would be the way to go, and that's where the supergrid comes into effect. This slide is interesting because it shows the change in annual average precipitation in inches in the last 30 years. And you can see the Southwest is becoming really dry. You know, they have less and less moisture falling. And you can see that to the dams are getting depleted and things like that. So they have a real problem there. We, on the contrary, we're in a good spot. If you were in BC this last week, you would know that we have a lot of waters and the hydro reservoirs are full, basically. So would it be nice if we can get the cheap solar generation sent up north to us, you know, to manage the reservoirs level, not to deplete that fast. And when they need when the sun is gone, you know, or when they have outage problems, we can send them hydro generation to the Southwest. So that's one example where this would work very well. Another example that was in the in the east there, where MIT study has shown that it will be a win-win situation to interconnect Quebec with with New Jersey and the Northeast. So what are the options for storage now? Of course, we have hydro, that everybody knows that. Pumped storage is another option, but it's, of course, it's more expensive than hydro. So batteries, it's a proven energy storage, but questions remain whether massive storage can be achieved economically.
Just economics.
Whether duration would be adequate or whether needed ingredients will remain available. And then, of course, we have hydrogen, the new kid on the block, whether it's blue, green, or pink. Hydrogen storage can be achieved by the use of underground salt domes, as Marshall already explained, for the Sarnia area. And we can also use depleted natural gas fields, of which there are plenty in Alberta. Of course, the pressure at which these hydrogens can be stored in these fields needs to be adapted. Northern Alberta not only offers abundant natural gas, but also numerous salt dopes and depleted fields. So it is thus uniquely privileged to become a massive hydrogen production and storage hub. And things have already started moving in that direction, as Air Products have announced plans to start construction on a net zero hydrogen energy complex near Edmonton. And we're talking about $1.3 billion here of net zero hydrogen production. So expected to begin operation in 2024. Now, this energy that they will produce there, this blue hydrogen, it can be, of course, exported by pipelines, but I think it can also be exported by wire. So just burn it on the spot and send it out by HVDC. So the White House made an announcement last April that underscored it's committed to accelerating the needed expansion and modernization of America's power infrastructure. Variable energy resources are expected to be the predominant new resources in all transmission operators and independent system operators. For the moment, these variable energy resources account for almost 90% of nameplate generation seeking interconnection to the transmission system across the US. And the United States has set a goal to reach 100% carbon pollution-free electricity by 2035. For the moment, there are also over 35 electric transmission interconnections between the Canadian and US power systems, forming a highly integrated grid. This will continue expanding with multiple cross-border transmission projects currently in various states of development. You probably are aware that the Quebec to Massachusetts transmission line going via Maine has been stopped now, and for environmental reasons. And as I go further a bit, you'd see, I think this is really a pity, you know, because the main opposition was that it destroys the beauty of those northern forests there in Maine. But nobody thinks about burying these lines. Why not? So anyway, so with hydro and energy resources north of the border and solar south of the border, there's a strong case to be made for a North American supergrid instead of concentrating on independent national, Canadian, or national US grids. Yeah, this just shows, I'm going to, for the sake of time, I will just skip over this thing here. But here, okay, regional transmission organizations are the organizations that do the planning for linking long-distance energy links. But as you can see on this map, there's not that many. There's all those areas which are wide. There's no regional transmission organizations. So it's basically the local utilities that do the planning. And of course, how are they going to connect with the next utility? That's always been a big problem. And we know that in Canada, between BC and Alberta, or between Quebec and New Brunswick and Quebec and Ontario, it always are big headaches to make links. Now, concentrating a bit on the Western HVDC link, you can see here, this is WEC, which is the Western Electricity Coordinating Council, of which I'm a member, and it shows all the transmission lines, in red all the 500 kV lines. So the savings in system operation brought by a new link would reduce new generation capacity required and reduce solar curtailments. And the cost of these links would be, the savings involved, I should say, should be much larger than the cost of the needed HVDC interconnection. It takes years to plan and obtain your right-of-way. And if you can obtain it, like in the Maine is the case in point, you know, which shows that it's so difficult to obtain. Now, just for your information, the main link cost $1 billion from Quebec to Massachusetts. And an environmental lobby spent $94 million just to work against that. So 94, that's about 10% of the cost of the line. It's amazing where all the money goes. So a better and faster option because of these problems could be to bury the new link on an existing right-of-way. If the right-of-way, a 500 kV right-of-way is existing, if you can use it to bury the cable there, that should take care of a lot of the environmental objections. Or how about the submarine cable of the western coast, let's say from BC straight to California? You could send stored water to south to California when you need it, and on the other side, bring solar energy from California back up to prevent depleting the reservoirs. So, and the thing is this practical? Now, there's two cases that I'm ending with, and that's the German SWEDLink. So, which the SWEDLink is an high voltage direct current transmission line, which is going to be the longest underground HVDC power cable in the world. For your information, Germany has now decided that all high voltage transmission lines in Germany will be buried, will be underground. So covering a total route length of 750 kilometers, this 525 kV underground power line will be capable of transmitting up to 4,000 megawatt of offshore wind power from North to South Germany, while also facilitating the transmission of solar energy from South to North Germany. The SWEDLink HVDC line will also be connected to the 525 kV Nordlicht HVDC subsea interconnector that brings hydropower from Norway to Germany. It has been identified as a project of common interest as part of the European Union's Trans-European Network Initiative. Renewable generation is much less expensive in North America than in Germany, and the case for a buried Western link would make even more economic sense. And finally, the North Sea link links Norway to Scotland, and it's buried in trenches on the sea floor, 720 kilometers long, 525 kV plus minus. So, and they have 700 megawatt per cable for a total of 1400 megawatt. It's in testing mode right now, and its cost was estimated in $2.5 billion Canadian dollars. As shown for these two cases, the SWEDLink and the North Sea, this proves that buried or submarine cables can be economical options for transferring renewable energy over long distances. Now, how to proceed, that is the question, right? So a week ago, I took part in the in a Grid Days conference, and in which I asked the question whether burying high voltage cables would be considered. And there was a guy from the United States, what was his name there? Haynes was his name, and he's the special assistant to the president for climate policy. And he answered my question, and he said, buried cables for HVDC, that is the future way to go. So they've been thinking about this already. Now, for North American transmission, maybe as a start, a Can-Am bilateral study group could be created with overseeing a scoping study. Or in the case of Western HVDC link, since Bcse, Hydro Alberta, and the Western United States are member of WEC, WEC could maybe the logical choice to host scoping studies once a heads of government bilateral memorandum of understanding has been changed. Or WEC could be instrumental in creating a Western regional transmission organization. So that's my hope. I think we're in a period of time where there's going to be a profound change in how we're going to transmit energy. So that's my presentation.